Right, I just thought I'd show this idea, which is basically it's a phono plate, which is from the phono board inside an old Technics amp that was broken, so obviously. I've snipped off all the components that were on the board to make it as flat as possible. And my local hardware shop that I get a lot of stuff from gave me this plate, a Details aluminium plate, which I've just cut really badly because I haven't got a workshop and I'm trying to use handheld tools like this pin vise. And when you're cutting something like that with, in a pin vise like this, you can imagine trying to hacksaw that. You can't keep a straight line. I mean, it's just purely functional, and what this is going to be is I'm going to mount this onto here. This is going to be the heatsink for two 100 watt 8 ohm loads, so that I can have a speaker load, because I've got a couple of amps coming that was spare a repair. So basically the idea is, this camera doesn't autofocus unfortunately, but you can just see on phonos, you can see the center contacts just go to the actual center circle with a little contact just here. I don't know if you can see that because it's blurred, but unfortunately until I get a better camera. Then you've got the edge, which is the outside or ground, and that's common to all of the connections on here. So I've got plenty to choose from. There's going to be just only two connectors used coming from speakers because the ground is common. So basically what I'm going to do, because they sit flush on there and they're actually pretty much in line, I don't know if you can see that, with the actual connector. So I'm going to obviously bolt with 2mm, using 2mm bolts that I got with the nuts and lock washers. I'm going to attach that to the center connector and then have the return coming back to ground on two of the resistors. So they're going to mount sort of like this, one there say and one on that side, so it's going to sit something like that and have the wires go back to the ground from there, bolted down, and then with heatsink compound on the back of the actual resistors to the metal plate. And then basically I've just got an 8 ohm load that I can connect instead of speakers when I'm doing signal measurements to test an amplifier, instead of obviously having a loud sine wave going through the speakers and deafening you and deafening yourself and annoying the neighbours, etc. So I'll give a shot of it when it's done and see what it's like. I said everything unfortunately has to be done on a desk with a pin vise, and it's but I've got a Dremel with little small drill bits to be able to drill through this and put the bolts through. So we'll see what it looks like at the end. And then when I get another oscilloscope, I'm going to buy one of those Furnessy ones because they're down to about £138 now, which includes a signal generator. Yeah, I know they're not great, but for what you get for the money. I shouldn't have got rid of my old oscilloscope, unfortunately, last year, but that's the way it goes. So I'm going to get one of those, and that will probably be here within the next month, and then I can actually start doing some basic amp repairs just to continue the hobby, really, and see how we go. So I'll get this bolted up and hopefully connected, and we'll see what the finished product looks like. So I've marked the holes. I've got this little draper kit it's got about 2mm drill bit, which is the biggest one. So just see how well it can handle going through really very, very soft aluminium. It's not the best conditions for sure. Yeah, it's gone through it. This is quite quiet, and except when it's drilling. It's probably taken the tip off the drill, mind. But anyway, it's done the first pilot hole, but what I'm going to use the Bosch and just to expand this out because I've got to get this these 2mm bolts through. So I've got to go up to 3mm just to do the hole, because that hole, as you probably can't see because of the light reflecting, but there's the hole there. So I'll get the Bosch out and I'll do it with the bigger drill. But I wanted to know what the Dremel's like. I've not used one before. I said I'm amazed there's actually that much charge in a brand new unit. So so I'll keep that on charge and see how we go. So the full kit, it's got a few drill bits in it and your polishing tools and stuff like that. So it wasn't bad value from the local hardware shop that gave me the plate. So I'll get the Bosch out and redo these with something a bit more manly, really, that can handle it. Yeah, as I suspected, I mean, these multi-tool kits, they're not really up to even just going through a soft piece of aluminium for long. It looks like, you know, it's blunted the drill bit that came with it already, and it's just drilled two holes basically, and now it can't drill the third. So, you know, like anything, you get what you pay for. So, but I'm sure I'll use it again in future. So it's time to get a real tool by a real manufacturer out and continue just to drill the holes. Yes, always using eye protection, kids. I don't take any risks with my eyes, especially where the way the NHS is these days. That's the last thing you want, is an accident. See, this is the problem, the way everything has gone now with this decay of society. You know, I'd put money on that this is made in China. It's not even written on it anymore. It says UK stamp on the box, but even so, it's still cheaply made. They can't even get their units right. It's got rated power on it here, and then it's got 10.8 volts, so they can't even get their power and their voltage units correct. So, you know, what does it say for just the demise of society with everything like this? And when you think this whole kit cost the best part of £40, and then, you know, a decent drill from my aircraft engineer brother that was in my toolkit, with a second-hand Bosch, God knows how old it is, but this is this thing. It's such a small handheld device. It's really powerful. So consequently, you know, it just went through this like butter in comparison, you know. So, you know, this was £6.50, I think, at a second, just a junk shop. In comparison to this that's got, you know, drill bits made of cheese that come in the pack. And, you know, you saw how long it took to drill the first hole, which was only a 2mm hole. So, you know, this is the exasperation, because you can't even do even half reasonable jobs for long with kit like this, because it just doesn't last. It's just garbage, you know. God knows what these drill bits are made of, but it's taken the end. Just a soft piece of aluminium has completely, 2 holes, and the end, you can't see it because this camera's crap as well. Again, you know, like everything else, it hasn't got any focus. It was only a cheap camera, but even so, it's still 20 quid, and it hasn't even got an autofocus thing on it as a standard webcam. But this drill bit with 2 holes in what? That's not even millimetre thick soft aluminium, and it's taken the head off that drill, 2 holes, and that's it. It's done. You know, it's just infuriating, especially the cost of everything now, which is absolutely insane for the garbage that you get. It's tragic, really. There's no pilot hole on that, which is why it was bouncing around a bit, but like butter, man, in comparison. Right, there's there's the board, the heatsink attached to the board with the 2mm bolts cut to length, so and screwed in. So now I've just got to put the mark these up to the right place, drill the holes for the resistors and fit those, and then solder up the wires and then check the resistance through to the appropriate phono jacks on the end, and then it's done. Looking at the way how far in the actual centre of the phono cable comes in to where I'm going to connect to, I can't solder directly because I think it would push on. It would be really difficult to solder in such a small space without connecting, dropping solder onto the earth and things like that. So what I think I'm going to do is use a piece of solid core copper and solder to the actual centre connector first, and then actually hook it onto this later, and then have the return path with heat shrink again just going straight to the earth. So it's a bit tricky to get it right. I know you can't see it very well with this shitty blurry camera, but you can see the gold tip of the lead as I push it in there. So I can't have this butted right up because it would push onto it. It's very difficult to solder that like that, so I'm going to have to see how I go with a separate piece. Of course, the problem is that I have to do that soldering first to get the length of the wire to know where to know the position of where the resistor is going to sit before I can mark the holes and then drill the holes to actually bolt this down. Actually, maybe not. No, I think I can. Even with this on, I think I can. I'm still going to be able to get the soldering iron in there. So I think I'll just mark this first and get the two resistors screwed down first, and then put the link cable in, the solid core link cable in after. It's probably the easiest way to go. I'm using the rather pointy end of this rectangular file, which is very sharp. I do have a punch somewhere. I certainly used to, but God, who knows since I've moved. Probably still at my brother's, but anyway, that does the job fine, so I'll drill those. Well, what I was saying about second-hand tools, yeah, maybe not. This is just failed, look. Now, it's seed solid with the smoke coming out. Lovely. And typical of life, it couldn't even let me finish the final hole before it decided to pack up. Wonderful. And so, ironically, after all I said about the crappy cheap draper, I had to use that to actually finish off the final hole in the backing plate there. So, life's funny for sometimes, eh? At least it does seem to have a pretty fast spin speed, this thing. And now when it's running, you can see all the actual lights charged up. But what's another annoyance that I've just realised is that being the battery pack, you can't actually, if this ever goes flat, that's it, it's dead. You're looking at a replacement battery again for this unit, which is the Storm Force, Draper Storm Force. Sounds remarkably powerful, doesn't it? So there's no actual ability to be able to go straight from the power pack directly into the unit if the battery starts to go flat. So again, it's the standard model of built-in obsolescence is still alive and well despite all the supposed green agenda to stop having landfill garbage. But there you go. By far the worst job of this little project has been actually cutting these two 2mm bolts with quite a blunt hacksaw blade, and obviously a non-fixed vice to hold stuff down. But these are the problems that go with not having a decent workshop and good tools. But you just plod on and take your time and do what you can, and get it done. If it takes longer, then that's just the way it is, and if it's harder on your hands or whatever. It's the same with doing the radio. When I had to, I didn't have the drill bit. The chuck wasn't big enough to take a 16mm drill bit, so I had to use a 12, I think it was the biggest it would take, and then file the rest out by hand. Just sit there for half an hour and plod on with a small or it was the larger one, a larger circular file to make the hole big enough for the mains cable. But these are the sort of things that are part of the fun of home projects, is coming across these types of problems and finding hacky kind of solutions around them. But that's just life in general, isn't it, really? So the only thing left to do now, a bit of isopropanol, and just wipe the surfaces. And then I've got this thermal grease that I've had for a few years now, this gold coloured, copper coloured stuff. It's worked really well and it's not too runny or anything. So I'm just going to put a little bit of, if it's still actually not gone solid over the last couple of years of being in a toolbox. So I don't really want much of this because I don't want it squirting out too much. And this surface is pretty flat anyway, so I'm not going to be too fussy about it. I don't really want it squeezing everywhere to have to clean it up again, really. So drop that on, get those in and then solder up, and then I can test it. Right, I'm going with a piece of solid 1.4mm mains earth here, and I'm going to you can clean any of the oxide off the end with just the serrations on the end of a pair of pliers. So I'm just going to put a bit of solder on the end of this, but the main tricky part is going to be getting just the right amount of blob of solder onto the actual contact without dropping it onto the earth and shorting it out to the ground pin. So I'm going to have to do it vertically so that solder stays dropping down onto the contact and not falling onto the pin. So that's going to be fun. So I'll have a go at that and see what happens. I'm going to have a bit of flux. I use flux for everything, really. It's just the way to go with solder if you want to try and get as decent connection and pain-free soldering as possible, especially, I think as I said before, if you're using the rubbish that I've got here at the moment, which is the solder, the silver solder stuff, not that it's got no lead in it, because it just doesn't run very well, so I don't really like it. Right, a solid core just isn't going to work because you need the flexibility after it's soldered, and trying to maneuver it to actually get into the right position to attach to the resistors is just going to snap off the actual connection that you're soldering onto because of the type of metal it is. So I'm going to try a piece of bell wire which is stranded, because then if I can just get it to solder onto the connection with reasonable strength, then the rest of it will be flexible enough and won't break off when I'm moving it to actually connect it over to the resistor end. So give that a go and see what happens. The other problem is everything's set up on this desk the way it is with the light. I need to be left-handed really to get the soldering iron in at this angle, so that's causing me a real problem as well to be able to hold things the way that I'd like, but that's life. Well, that braided, what I thought was braided is not. The speaker cable is bell wire, and it's actually solid core, so that's no good either. So I've got some RG59 or whatever it is, so I'm going to try that. That's flexible, it's got braid on it, so I'll strip some of the braid and try and use this somehow. Right, finished the wiring. I've got the cheap leads joined together, which you can see the combination of the two is giving 1.4 ohms before we even start as far as a resistance. And if we go across each of these power resistors, these 100 ohm 8 watt resistors, you can see they're reading 9.4, so they are pretty much bang on 8 because of that extra 1.5 ohms of the lead resistance. So you can see there that that other one is 9.4 as well. So each one is accurate enough, but using the actual jack, the Phono lead connections, and probably this is a cheap lead as well. This was just a £3 one from Cash Generated, etc. So this will probably have quite a bit of lead loss as well, but it's actually a lot. So the way this works now, I've taped up all the other phono holes that aren't relevant, so I've just got the two that are actually connected. obviously the signal comes in on the center pin, goes through the resistor and back to the individual ground. Now what I said earlier, there must have been a misreading. I don't know quite what happened there, but all of the grounds on each individual one they're not connected at all. They are separate for each input. So obviously what will be happening is this effectively, instead of having a lead like this, you'll have the phonos at one end only with these chopped off, and then these would connect into the actual back of a speaker connector on an amp with the little whatever type of clip connector it may be. Excuse me. So you'll only have obviously the positive and the negative going through if this was the equivalent of each of a speaker. So each circuit goes from the pin, the center pin, back to its own ground through the 8 ohm load. So measuring across each one, if I connect to the outer shield on one, you'd expect, all in an ideal world and good cables, to actually read not much more than the 8 ohms of each one, but I'm actually reading 16 ohms on a single one. And that's the same for the other side too, so it really goes to show that the combination of solder joints and cable losses with cheap cables, cheap phono cables, plus the cheap leads, so you can see I'm getting 15.8 there as well. And the final build, again blurry on this camera, but it's basically just straight, as I've explained, it's straight through from the center pin through the resistor and back to the ground for each individual phono socket. But hopefully, I mean, it's only, you know, provided they're both the same losses, then hopefully everything's okay. And it's not a reactive load anyway, which a speaker would be. So, you know, and the type of tests I do, if I fix an amplifier, then, you know, just doing a basic frequency response curve isn't really that accurate. It's just to show that everything's sort of working really. So it's not important, but anyway, it was something to do, kept me occupied for a few hours to say the least. And it's just something that you could knock up from, you know, having a phono board from, say, a dead amp, and just take all the components off and rig something up similar, probably a lot tidier than I've done. But anyway, it's finished and it works, so that's the end of that.